Hey everyone, welcome to 8.2 Notes. We're going to be talking about ellipses. Today we're going to talk about how to graph them, and next time we're going to actually talk about how to write the equations. So we'll be talking about these for 2 days. First things first, the major axis is always going to be the longer axis of symmetry, and the minor axis is always going to be the shorter one. It's not really that hard to keep track of them because one's longer, one's shorter. Major usually means something bigger anyway. Minor usually means something smaller anyway. The center is just like the center of a circle, so it's the point in the middle where the major and the minor axis intersect. And I'm going to come down here and kind of draw you an example before we get too far into these vocab words. A horizontal ellipse, it's kind of like an oval. A horizontal one means it's more side to side than it is up and down. And it means that this axis is longer than this axis. So notice how this one is shorter significantly than this one. The vertices are the ends of the major axis. So major and vertice go together. These are sort of like the captains. So these two would be my vertices since they're on the longer side. Co-vertices are kind of like co-captains. They're still important, but not quite as important or not quite as big of a deal. They are the ends of the minor axis. So that would be these two. And really the only thing you need to remember is that co-vertices are going to be along the shorter side and vertices are going to be along the longer side. And basically what's happening here is it's kind of like a circle, but since it's skewed or not perfectly round, the x-axis kind of has its own radius. We're going to call that A, and the y-axis has its own radius. We're going to call that B. And instead of, I'm going to kind of start with what we had with a circle. We started with that, and we had it equal r squared over here. Since each one gets its own, we can't just put r squared over there. Instead, we're going to put a 1 here, and the radius squared for each one goes on the bottom. So a squared is going underneath the x parts because it's the x radius per se. And the y has b underneath because that's the y radius per se. It's not exactly a radius anymore since it's not all the same, but you can think of it like one. And the only thing that's going to change over here for a vertical one is now we have an oval that's more going up and down because the longer side is on the y's. The same thing happens though. It's almost exactly the same equation, except A and B switch spots. So A is always the longer one, and B is always the shorter one. A is always bigger. So X gets the bigger number underneath if X is longer. Y gets the bigger one underneath if Y is longer. It's really not that complicated. It's more complicated if you try and keep track of the letters, honestly. And the center is just HK. Kind of like it was, again, when we did circles. It's kind of the same structure, you just have a little bit of fractions now. The vertices will always be A units away from along the major axis, and the covertices will always be B units away from the center along the minor axis. So for this one, these are my covertices because they're shorter. For this one, these are my covertices because they're shorter. So it's going to switch sometimes whether it's this way or this way. It's just always which one is shorter and which one is longer. And then there are these 2 points called the foci. And the foci are C units away. I'm just kind of going alphabetically A, B, C. They are C units away from the center, but they have to also be kind of along the major axis. And there is a formula to find it. It's almost like Pythagorean theorem, but you subtract instead of add. I'm going to make a note of that because everybody thinks it's adding because that's Pythagorean theorem. Right, and I'll draw these foci down here for you so you can see what that looks like. They're a little bit confusing because they can give you lots of fractions and decimals. The other parts of it are a little bit easier though. So what I'm going to do is everything except the foci for right now on both of these, and then I will come back and do the foci. The center of this one, there's nothing in the parentheses, so it's 0, 0. So I'm going to go put my point at 0, 0. And this next part, you can do mathematically, and I'll explain how, but it's a little bit easier just to graph it out first. So underneath x, we have 4. This is sort of like the radius of x squared. We don't know if it's the shorter one or the longer one, though. I mean, we can figure it out, but it doesn't really matter because the square root of 4 is 2. I'm going to go 2 in both directions. And I'm not dividing by 2, I'm doing the square root. And the square root of 36 is 6. So then I go up 6 and down 6. Like that. And that is the main parts of my ellipse. So now my vertices are the ones along the bigger side. So that's these two, which is over 0 up 6, 0, 6, and over 0 down 6, which is 0, negative 6. And my co-vertices are over 2 up 0, so 2, 0, and left 2 up 0, so negative 2, 0. Now, here's how you could have found that. Since the bigger number is under y, you could have taken this number and added it and subtracted it to the y's, but left the x's alone. Since the square root of this was 2, and it's underneath x, that's the smaller one, so for the co-vertices, I could have added and subtracted 2 from the x and left the y's the same. You're really only changing one variable at a time because it either goes up and down or left and right, but not both at the same time. Okay, let's do the same thing over here, except for I'm just going to go a little bit quicker. The center is the opposite of these two numbers, so that would be negative 1, positive 2. That's trying to tell us to go left 1, up 2. There you go. The x's have a 49 underneath. The square root of 49 is 7. So I'm going to go 1, 2, 3, 4, 5, 6, 7 to the right, and 1, 2, 3, 4, 5, 6, 7 to the left. Then my y value underneath is 9. Square root of 9 is 3. So I simply go up 3 and down 3 and draw myself an ellipse. This time the x's are bigger or longer, so I'm going to basically add 7 to negative 1. That gives me 6, 2, and subtract 7 from negative 1, negative 8, 2. I can also count that out on the graph. 1, 2, 3, 4, 5, 6 up 2, and 1, 2, 3, 4, 5, 6, 7, 8. Let's count that again. 1, 2, 3, 4, 5, 6, 7, 8 up 2. And again, I got lost a little bit. These squares are kind of hard to count, so it's almost easier to just count in your head. If you knew you were moving 7, add 7, subtract 7. My co-vertices are a little bit easier. This one was only 3, so I'm going to add 3 to the 2. That's 5. And subtract 3 from the 2. That's negative 1. The other variable stays the same. So you just kind of have to pay attention to which one you're changing. Now let's talk foci. So I already kind of had said that c squared is a squared minus b squared. I'm going to write another formula underneath here where I've already done the square root so that I find out what just c is. So in this case, c would be the square root of 36 minus 4. You're always going to subtract those two denominators. And the square root of 36 minus 4, or the square root of 32, and I apologize, this is going to look, yeah, definitely shattered my phone screen, y'all. Square root of 32 is about 5.7. So what that means is from the center, I'm going up 1, 2, 3, 4, 5 and a half-ish, and down 5 and a half-ish. So the foci are these 2 points kind of on the inside at 5.0, 5.7, and 0, negative 5.7. Because just like I did here, I'm just taking this number and adding it to the y values and subtracting it from the y values because the y values were my major axis. Over here, same thing, but it's 49 minus 9, which is the square root of 40, which is about 6.3. So I would go left and right 6.3, which means that my foci would be -1 plus 6.3 and -1 minus 6.3. Again, I'm changing the x values because my major axis is the x's on this one. And the y value stays at 2, which means I'm going 1, 2, 3, 4, 5, 6 and a third, and 1, 2, 3, 4, 5, 6 and a third. So the foci are just barely on the inside of the ellipse. And that's all, folks. Oh wait, I did forget. Hang on, there was one more. If there is not a 1 on this side, divide everything by that number. 9 divided by 144 is 1 over 16. And 16 over 144 is 1/9. What's going to happen every time is this one is going to end up with this as the denominator, and this one is going to end up with this as the denominator. We're going to sort of just like switch and move to the bottom every time. There are no parentheses up here, so my center is 0, 0. Right in the middle. The square root of 16 is 4, so I'm going to go 4 to the right and 4 to the left. The square root of 9 is 3, so I'm going to go 3 up and 3 down and draw my ellipse. Now, my vertices are these two along the x, because that one was a little bit longer. This one was 4, this one was 3. So I'm going to add and subtract 4 to the x part of my point, which gives me 4, 0 and -4, 0. My co-vertices are these two, which was 3 away, so I'm going to add and subtract 3 from the y part, but the x part will stay 0. And finally, for my foci, I do the square root of 16 minus 9, always the biggest one minus the smallest one. 16 minus 9 is 7, and the square root of 7 is 2.6. So what I can do is go back to my center along my major axis. The big one is go about 2.5 each direction, like that. So this time you can actually see the foci in the middle. If I add and subtract 2.6 the same way I did this 4, so it should be changing the same number you did on the vertices. That's going to be 2.6, 0, and -2.6, 0. Now, you might be wondering why these were a little bit further in. Because this one is getting closer to a circle, since 3 and 4 are way closer together than, let's see, what was it? 2 and 6 or 7 and 3. So as your radius for each variable gets closer, it becomes closer to being a circle. On a circle, the reason why we didn't have to do these is because when this becomes perfectly round, these two foci go right to the middle.